December 1st. All right, fellas, listen. I mean, we've been doing this graphing for a while, and we're getting close to the end here. I'm going to talk about that capital C factor today. Remember, there was a capital A, a capital B, a capital D. Now there's a capital C. Tomorrow is going to be like combinations, and then Monday I'll kind of wrap up. But the next test, the entire test, I'm just going to give you problems and say graph them over one period or over two periods. Okay, now look at the handout, because a lot of this is just on the handout. Consider a function of the form y equals cosine of x minus c. Now, in your notebook, everybody write down this right here. Right here. All right, you know what? Here, let's do this like this. Well, no, we'll do this one first. Just write that down. Now, I'm not even going to put VT down. Because again, the only time there's a vertical translation is when a number is plus or minus after it, which is not there. All right, now look what it says in the paper. Because once you get the concept, this isn't that bad either. It says graph y equal cosine of x and y equal cosine of x minus pi over 4 on the same coordinate plane. Now just follow me on the handout. The graph of y equals cosine of x minus pi over 4 has the same size, the same shape, the same amplitude, the same period as y equal cosine of x, which is just right there. First, I'm going to do y equal cosine of x, which you already know how to do. Now, the only time you have amplitude is for sines and cosines. What's the amplitude of this? Same as before that you learned. Somebody. What's the amplitude of that? Ethan. It's 1. It's the absolute value of the number in front, which is a 1. Now, the period is the capital B number. The capital B number is the number in front of this parenthesis, which is also a 1. So what's the period here? Howard? 2 pi. Okay, now watch this. The graph of that is going to be the same as y equals cosine of x, but look what it says in the paper. It's going to be shifted to the right by pi over 4 units. Now this is the C factor. The capital C factor is the angle in the parentheses. This is called the horizontal translation, which in trig is called a phase shift. So I'm going to go PS for phase shift. Okay, now just listen to me before I start to show you this. In general, I'm about the middle of the handout. The graph of y equals cosine of x minus some capital C is congruent to y equal cosine of x. It's going to look exactly the same. The only difference is, now look what it says here. It's C units to the right if the C is greater than 0, but its absolute value is C units to the left if C is less than 0. Now let me make this real easy for you. When it's x minus something, that C is positive. The minus is just x subtract whatever the angle is. So what I'm saying to you here is the phase shift here is pi over 4 to the right. Now make sure you're getting this down. Here, you know what? Leave yourself space in your notebook for the graph and write this down. Now space this out. Write this down. I'm going to do these at the same time. Then you'll be able to see the difference.
How do you know that it goes right?
Hold on. I'm going to re-explain it. Leave space for the graph here and write that one down. Put amplitude, put period, and PS is phase shift now. Now, do you see what I'm doing here? There's the A factor. There's the B factor. There's the C factor now. Okay, there is no D because we don't have any plus or minus a number. So what's the amplitude in this one? Obviously. Robbie? 3. What's the period in this one? Ethan? 2 pi. And now, to answer your question, Ethan, let's keep this real simple. If it's x minus some angle, C is technically positive. I mean, this is cover up the minus sign. See, that says x plus pi over 2. So technically, x minus a minus pi over 2 is how it became x plus. So when it's x plus an angle, the shift is always to the left. When it's x minus an angle, the shift is always to the right. Now that's the easiest way to remember this. You don't want to screw that up because you got to make sure you're going in the right direction. So the phase shift here is pi over 2 left. Now watch this. Go ahead, draw your graph like you always do. Now go ahead and mark your quarter increments just the way you've been doing. That's all the same. And label them. You only have to label the ones on the positive side. Go ahead and do that just the way you've been doing it. That's the same as it's always been. So this is 2 pi, so you cut it in half, you cut it in half, you multiply by 3. Same thing over here. Cut it in half, multiply by 3. Okay, now what I'm going to do here, I'm just going to grab y equal cosine of x first. So 0. What's the cosine of 0? It's 1, right? 90. What's the cosine of 90? 0, right? Now you guys should have a pretty good handle on these. Now, remember the sine and cosine graphs? Waves? Where's this one going to have to be? No, we already did this now. Please, let's get this straight. This one is at 1. This one's here. Where's the one of pi going to have to be then? Somebody? Smooth wave, just like before. Ethan? -1. This one's going to be 0. And this one's going to be back up here. And then over here, fill in. Here, 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 and there. Now, go ahead and connect those just like we did before. There. Now, do you understand that that is not the graph of that problem? This is the graph, you see what I just boxed in, the y equal cosine of x. So what does this phase shift mean? Can one of you tell me? I'm going to take that graph and shift it how? Come on. Remember when we did vertical translation? It's very similar to that, but we're going horizontally with phase shift. Jack? Pi over 4 to the right. Now, you guys have to be smart about this. Here, let me extend this out a little bit. Same thing over here. I have a problem here. Can one of you tell me what my problem is? I'm going to take, you see all the points right here? I'm going to take each point and shift to the left pi over 4. That's 45, right? Degrees. What do you think I have to mark on this graph before I can even do that? Why am I saying I have a little bit of a problem here? Jack. I got to cut, this is 90, 180, 270, pi 4. I would have to cut that in half there. Do you see that what I'm saying? Because if I cut it in half, isn't that pi 4? So everybody, go ahead and cut them all in half. Just cut them in half. Okay, now what's the phase shift? 45 degrees to the right. So all I'm going to do, now I cut these in half. You know, maybe I should have made these a little bigger here. 45, to the right 45, to the right 45. Now what do you think I'm going to have to do over here? I'm going to have to add another one there. And then there's 45, to the right 45. And just look. Now, that's the first example, but I need you to understand what I mean by phase shift. Do you see what I did there? That's done. I took the basic graph and I shifted it 45 degrees to the right. Now, look at the second graph up here. Right there and graph that first. Actually, you know what? What am I going to do here? And then you're going to say, can we do that? And the answer is going to be yes. I'm putting both up here because I want you to see the concept. Now you know that,